All right. Hi, everyone. It's Mrs. Zimmerman and Mrs. Kautsoulis. We're back again for more math, and we are just as excited as you are. So, we are getting almost to the end of the school year. How crazy is that, Mrs. K?
It's crazy. It's May, Mrs. Zimmerman. May.
Yeah, I'm feeling it too. So, we got a lesson today, more inequalities. Remember the alligator mouths and the graphing? Yeah, Mrs. K's got more of that for you today. So why don't you take it away for us?
But first, we must have a fish update. How are the fish doing in Thomas's bedroom?
Yes, okay, so I already told you guys my fish are in Thomas's bedroom. That's my 4-year-old. We've got a pretty good routine now. He gets up every morning. He feeds the fish. If Henry's awake, my 2-year-old, then we fight over who feeds the fish. And so they both really like to feed him. So we kind of have to take turns sometimes to make sure that it's fair, for both of them. But
Can you feed fish too much food?
I don't think so, because whatever they don't eat usually just sinks to the bottom.
Oh, okay.
So I don't think you can overfeed them. And then my snails will eat that food, I think.
Oh, sure.
Because they're pretty fast. And actually, some of you in my class know this, but you remember Honey, the yellow snail? She likes to crawl up to the top of the tank, like suction on the side of it, and then she likes to drop off and float to the bottom. She plays this little game, and Thomas literally just sits and watches her. She does it usually in the evenings for like 2 or 3 times, and he just about loses it. So we're doing good. They're all still alive. We're just keeping them swimming.
And I hear you made a snowman with Thomas and Henry yesterday with the snow. How about the snow, guys?
Yeah, I know, crazy. Right? Can you believe it? We had snow on Easter. Oh my gosh, that's crazy. But yeah, we built a snowman, so that was good too. Yeah.
Well, I suppose we better get started. And I'm so excited because today's lesson really works well with the lesson you had last week. All right. So before we start, I'm going to review what we did in chapter 6 when we were solving equations. And when we solve equations, remember, all we want to do is figure out what does that variable stand for? What does that variable, what number or fraction does that number stand for? So I am bringing a blast from the past. And I have an equation here. And here's my equal sign, so I know it's an equation. You don't see an inequality sign here. And if I want to know what x is, what do I have to do, Mrs. Zimmerman?
We have to use inverse operations.
Inverse operations? What are inverse operations?
Inverse operations. You guys remember, right? If it's a subtract, what's the inverse of subtract? Add. And it's the same for multiply and divide, right? The inverse of multiply is divide, and divide is multiply.
So I just did the inverse of subtraction, which is what Mrs. Zimmerman just shared with you. So I have a minus 15 in order to get rid of that, because remember, when we solve equations, we want x, or the variable, by itself. So we did the inverse, and we're showing our work. We added 15 to both sides of this equal sign, because remember, whatever you do on this side, you must always do on the other side of the equation. And so when you are solving this problem, a negative 15 or minus 15 and a plus 15 on a thermometer would get you at 0. And so we just cross that off, and all we have left on this side is what, Mrs. Zimmerman?
X.
X. And then we go ahead and do the math on the other side, and we allow you to use calculators, but Some of you are very good at mental math. You know that 135 plus 15 is 150. Now, this is what we did in chapter 6, and you were very, very good at it.
Mhm.
Let's try one more just to make me feel better. By the way, I really appreciate it when you email or text Mrs. Zimmerman or myself with questions.
Mhm.
We get lonely here at home, and well, maybe not Mrs. Zimmerman. She's got all those 2 boys to chase after. But Mrs. K, I get lonely sometimes. I really miss you guys, and so make sure if you don't understand, you get a hold of us. All right. So now this time my X is here, and if you recall, when you have a number, a decimal, or a fraction next to the variable, it means that you are multiplying. So now we need to come up with the inverse of multiplication, Mrs. Zimmerman. What would that be?
Division.
Division. So I am going to divide, and I apologize, I have to write this on the counter here. Okay. So I have to divide by 1/2 on both sides. And we know then that 1/2 divided by 1/2 is 1. And 1 times that X is X. And if you take 40 divided by 1/2 and do it the long way, or if you change 1/2 to 5/10 and you take 40 and divide it by 5/10, you get 20. Actually 80, sorry. This K went the wrong way. So 80. 40 divided by 1/2, or 40 divided by 5/10 equals 80. So remember, when you're trying to get your variable by itself, you are going to do the inverse or the opposite operation to get X or any variable by itself. Mrs. Zimmerman, did I forget anything?
I don't think so. That looks great.
Okay. So now the great thing about today's lesson is that we are just going to do the same thing. The only thing that's going to change is instead of this being an equal sign, it might be a greater than sign. And we do it exactly the same way. Or it might be a greater than or equal sign. Yeah. So you're going to solve inequalities the same way you solved equations. Let me share some examples with you. Okay, Mrs. Zimmerman, can you see that?
Yes, I can.
Okay, so we are in week 7, and this is solving inequalities, and we're going to solve them the same way we did equations. So here I have an inequality, and instead of an equal sign here, I have a greater than sign. Just ignore it. It's not going to change the way you solve it. So we have this variable X, and we want it by itself. So we're going to do the inverse or opposite to get rid of this minus 5. Well, the inverse or opposite of minus 5 is plus 5. And remember, what we do on one side, we must do on the other side. So a minus 5 and a plus 5 make 0. And so all we have left on this side is X. We keep the same inequality sign. We don't do any flipping around with that. We just leave it alone. And then we add 2 plus 5, and we get 7. That means X is greater than 7. That means I can pick any number greater than 7, and it's my answer. So Mrs. Zimmerman, what's one number that X could be?
How about 13?
Is 13 bigger than 7? Sure. So 13 is a solution. Mrs. K is going to pick 67. 67 would be an answer because it's bigger than 7. Could 7 be an answer, Mrs. Zimmerman?
No.
No, it couldn't, because 7 is not greater than 7. All right, let's try another one. This is red. 10 is greater than or equal to a number z minus 1. So I want z by itself. So I'm going to get rid of the minus 1. The opposite of minus 1, or the inverse, would be what, Mrs. Zimmerman?
Addition.
Addition. So we're going to add 1 to both sides. So a negative 1 plus 1 on a thermometer would get me to 0. So z and 0 is z on this side. Remember, don't switch sides, guys. My variable's on that side, so I'm going to leave it there. I'm not going to change my inequality sign. I'm going to leave it the same, and then I'm just going to add 10 plus 1, and that's 11. So, Mrs. Zimmerman, can you give me an example of an answer for z? What would be one that would make this true?
Let's see. 11 is greater than or equal to 4.
Correct, because 4 is tinier or less than this 11. This says 11 is greater than or equal. Now, in this example class, I could make z 11. I could do that because we have this little equal sign down here. So 11 can also be equal to 11. So my choices could be 11, they could be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and then any negative number in the number line. So the answers are endless. Okay. Now Mrs. K changed her directions. I want you to solve it, but then I want you to graph it. And I know you know how to graph because that's what we did last week. So we're going to put those two items together. So here we go. Let's solve first. I have a y plus 2 is greater than or equal to 13. I want to get rid of the numbers next to my variable. I want y by itself. So the opposite or inverse of plus 2 would be minus 2. And I have to do that on both sides. So if you remember, this plus 2 and this minus 2 on a thermometer would give me 0. If it's 2 degrees out and it drops 2 degrees, it's 0. And so all that's left on my left side is the letter or the number y. And on this side, 13 take away 2 would be 11. All right. So we have done the first part of the problem, solve it, and now we're going to graph it. So I'm going to pull up my number line here. And remember, when you have y all by itself, you're going to have a number over here, and that's your starting point, 11. So you can see I graphed 11 down here in the corner on my number line. Now I chose to use a closed circle. If you remember from last week, a closed circle is used anytime you have a greater than or less than sign along with an equal sign. Because remember, we just said that 11 could be the answer. So we want to make sure that anybody reading our graph knows, yep, 11 could be an answer because it's a closed circle. All right. Now, all my y's, are they going to be bigger or less than 11, Mrs. Z?
Bigger.
They're going to be bigger because it says here, y, anything y, all my answers are going to be greater than 11. So my arrow class looks like this. Can you see it down there? It's really short, teeny tiny, but it's going to the right because that means every number 11 and over can be an answer to this inequality. All right. So we are using solving inequalities this week, and we're pairing it with graphing from last week.